I can see them again.
No.
Oh, now we can.
It's all right. There's about a 30-second delay.
Shall I just stick the questions this way? And that should be okay. LabVIEW. Is she okay?
There's a 30-second delay on it. So it's just going on.
This is live now.
Yeah,
I'm still there. What you can do is like turn this bit, it's like improv. Is that good? Yes, that's what you.
that just looks like
That's quite far out here, isn't it?
it just looked like my laptop is really slim.
Except with a huge
Like staring.
something else.
Oh, yeah.
Check out.
Yes, you're alive.
Get back to the start. Okay, cool. Right, in their life. So, yeah, welcome to the third London LabVIEW user group. My name is Peter Davies. I work for Austin Consultants. Obviously, we work with National Instruments to put this together. I've been told that we need to think about a logo to make us on par with the other user groups, which should have cool logos. So we can work through that. 2 seconds on who we are. We are Alliance Partner. We've been going since 2008. We've got 8 certified LabVIEW architects. Hopefully should be up to 10 in a couple of months. And yeah, I think the UK's highest certified integrator. Work with various clients integrating LabVIEW. LabVIEW is a specialization in the company, and that's kind of our key focus. It's keen to work with the user groups. So with the user groups, as discussed, it's more importantly, who are the team, who are the people we've got here. So if everyone wants to just kind of introduce themselves, just give a kind of quick name, quick overview, and we'll just do a quick walk around the table. So, both, you want to start?
Okay. I need to stand on camera. Hi, this is Bofu, and I work for Austin Consultants. I'm a data scientist. I deal with signal processing and data analysis. I'm a CRA, by the way.
So I'm Imtiaz Chowdhury. I work for Green Running as a project manager, and I've been working with LabVIEW for a few years at National Instruments.
Hello everyone, I'm Petru Tarabuta, and I've recently started as an intern at Austin Consultants, and my job is to create a demo for the company. I've done LabVIEW for 2 years, and I've done an industrial placement with National Instruments prior to this.
Hi everyone, I'm Peter Horn. I've been working with NI or at NI for nearly 12 years now, which makes me feel really old. Certified LabVIEW architect, certified test stand architect, and I do lots of LabVIEW and PXI test related things with customers.
Hi guys, I'm Chris Garrett. I'm field sales engineer for the southeast of England, so that's kind of Essex, Kent, and then a bit of East London as well. I've got a reasonable amount of experience with LabVIEW and test stands, so I'm certified in both. I'm going to put a slide about myself in a minute anyway, so I won't ramble on too much.
Yeah, that's the same for me. So I'm Maria McCaffrey again from NI, but I cover West London and Surrey. So the role kind of is in London. If the postcode has an E in it at the beginning, it's Chris. If not, it's me. And yeah, we kind of go out in the 2 different directions. And there's also a slide on me coming up, so I'm not going to say anymore.
I'm Nikki Davies. Sadly, I have no slide, but my role is the head of marketing of Consultants and Green Running. As Green Running kind of grows, I'm going to be moving more on Green Running more full time and coming kind of off the Austin stuff, which I'm quite sad about because I really loved it in the last 2 years. But generally, with the Austin stuff, my role is to promote the work that these guys do and shout about it, and obviously make sure that everyone's there and our partners and clients.
Cool. Yeah, Miss Me, I suppose. Peter Davies, I'm also a CLA. Yeah, been working with LabVIEW since 2003, maybe. I'm one of their head engineers here at Austin Consultants. Cool. Okay. So the user group, what it's about, obviously, it's pretty much about whatever we want it to be about. It's all users in London using LabVIEW, and kind of we have the freedom to, we've got a bunch of really clever guys around the table and a bunch of LabVIEW enthusiasts trying to make it what we want to get out of it. Whether that be presentations about companies and the projects they're working on, or cool features we want to see, and examples in LabVIEW, and just general topics which provide interest. So for this one, the agenda we've come up on is a quick, well, not quick, an overview for NI Week, which a few of us around the table were lucky enough to attend a couple of weeks ago. And then we're going to have quite a technical one from Dr. Fu about the hidden Markov model and machine learning. And then Peter Horn's going to blow our minds with the assertion toolkit. And then we kind of do a bit of a wrap up, ask the expert if there's any questions online, etc. And various teas and coffee. So on that lovely note, I'll pass over to our National Instruments group.
Have we got people on there?
Yeah, I was just thinking about this slide. Do you want to leave it to the end?
Oh yeah, that's Sorry.
We'll come back to it.
We will come back. That's fine.
Sorry. Sorry.
Okay, guys. Hello. As I've just said, I am Chris Garrett, FSC for the South East. Just quickly, so we're going to cover a few topics within this. So myself and Maria are going to quickly introduce ourselves in a bit more detail, just to give you an idea of who we are and sort of where we come from within NI. I'm going to cheat a little bit and play a couple of the NI keynotes, which I think are particularly relevant for this year, and show some of the key themes from NI Week, and also some of the cool applications that people are working on in the UK. Maria is going to then go on to new product overview, including what's new in LabVIEW demo. So should be exciting. That'll be the main thing for the day. So followed up, if we've got any time, by any questions kind of on NI Week or any of the new products that we've kind of mentioned. Okay. So without further ado, here I am. So my kind of history with National Instruments, I actually joined the company in 2010 as an intern. Tom Petrie has just finished his internship. I spent a total of 16 months as an intern with National Instruments, and that was in the application engineering department, so supporting customers with their applications. I'm sure everyone in the room has either been in that department or called that department at some point during their time using LabVIEW. So I came back to National Instruments as a graduate in 2013, and since then I've kind of worked my way through. So I went back into the application engineering team, as part of that, teaching courses in LabVIEW, so real-time FPGA, LabVIEW, instrument control as well. Moved into the sales team last year, and then moved into the field sales team in February this year. Just kind of a note on there, I am a certified LabVIEW developer and a certified test stand developer, so I do actually know what I'm talking about when it comes to the software side of things. So I'm not just going to try and sell you stuff, I can actually help as well. I put my contact details on the bottom there, just in case anybody doesn't have them. I haven't actually got any business cards with me, so feel free to drop those down. Maria's just going to jump in for a second.
Around the side, so as people can't see me, you can just keep it saying hello. So I'm the FSE for West London and Surrey, so exact same role as Chris, but just covering a slightly different territory. So yeah, I've been using NI stuff for 6 years now, so heavily as part of my degree, and then I did a research post as well in wireless sensor networks using the NI USRPs, and so a bit of kind of an RF background. And then after that, I worked for a telecommunications consultancy, which is Mason Communications up in Manchester, and during that time, a lot of the projects I focused on like government and a lot for the transport sector, so the European Railway Agency. So kind of technical, but more kind of business focused than my role would be now. yeah, then I joined NI last year as an applications engineer and taught courses the same as Chris. Did my CLD and then moved to sales at the beginning of this year and then into the field sales team in May. And again, my contact details are there. I did manage to bring business cards, 1 point for me. But yeah, obviously anyone on the phone, feel free to note those down and give me a shout if I can help with anything. Back to you.
Fantastic. So we just wanted to show you a couple of the important keynotes from NI days, NI week days. The first one that I wanted to look at was Jaguar Land Rover. So they've done a lot of work in data management, and data management was a really big theme for NI week this year. Talking about the whole end-to-end solution. So from the point of acquiring data all the way through to your IT infrastructure and being able to manipulate that data and look at trends. So I think Maria is just going to switch over onto a different laptop for you, and we'll play that. But if there's any issues with sound, please let us know so we can sort that out. On his next one. It's the next one. It's already
Let's see, we got it already up. Sorry with that.
Yeah, so I'm excited to be out there and showcase some amazing innovation from customers that are doing research, testing products that interact with the physical world. From scientific research to mechanical valves and actuators to full-scale electromechanical systems like cars and planes. With the proliferation of sensing and networking technologies, it's never been easier or as cost-effective to add measurements to your systems. Our compact DAC platform is a great example of this proliferation. From our low-cost Wi-Fi single-seat devices, to our multi-slot chassis and controllers, to our over 60 I/O modules for connecting to any sensor or any signal. And today I'm happy to kick off the NI Week product announcements with the highest bandwidth compact DAC chassis to date. Today we're releasing a 14-slot USB 3.0 chassis that can stream measurement and sensor data at up to 225 megabytes per second. Let's give the compact DAC team a round of applause for this accomplishment. And as measurement systems like these continue to increase in performance, and you guys continue to measure more, the amount of data is increasing exponentially. So Eric mentioned earlier that you, our customers, have generated over 22 exabytes of data in the past 3 decades. Well, recent analyst data shows that on average, companies are only analyzing 5% of their data. So that's a ton of potentially critical data that's going unused and unmanaged. Using the NI Week app, we polled a lot of you to see how much time you spend just per week searching for measurement data. With those results, doing some quick math, in a room of 3,500 engineers, we will spend $17 million in the next year just searching for measurement data. $17 million. That's insane. So how do we solve this big analog data challenge? Well, step one is with more intelligent measurement systems. Smarter measurement systems powered by LabVIEW system design software allow you to embed more processing at the point of acquisition, capturing only the most critical data needed. Step two is with smarter data management. An enterprise data management solution is paramount. In the end, we want to make sure that you get the most critical data in front of the right people in your organization to make data-driven decisions faster. To show us all how to solve this big analog data challenge, please welcome from Jaguar Land Rover, Pablo Abad, and from National Instruments, Stephanie Amrite. Pablo, Stephanie. So thanks for making the trip from the UK, Pablo. So tell us a little bit about Jaguar Land Rover and your application.
Sure, Tom. At Jaguar Land Rover, we invest in research and development more than any other manufacturing company in the UK. And our powertrain R&D engineers generate up to 500 gigs of data per day.
Wow, so 500 gigabytes of data per day. So that's quite a bit of data. So what challenges did you see managing this data?
Yeah, we were finding it difficult to manage the amount of data we were generating. We were often repeating tests because we couldn't find specific test results. Our analysis routine was based off a manual process, which by our estimates was up to 20 times slower than the current automated process we have now developed.
So Pablo, can you explain why the analysis was taking so long?
Yes, so we had multiple tools for analyzing the data. Each of those requires specific scripting for implementing algorithms. We didn't even have our metadata standardized, so this process led us to being able to analyze just 10% of the data we were collecting.
So it's taking you 20 times longer, and you were analyzing up to 10% of your data. Can you show us a demo of how you solved this big analog data challenge?
Of course. So the first thing is that we have multiple tools for analyzing and collecting the data. So NIDIADEM is compatible with any of their file formats, regardless of their source. So once the files come into our system, what we do is that we calculate some additional parameters, and we sort the file along with their metadata in our server, which is based on NI Data Finder Server Edition. And from there, an engineer can query the database. So the example that I'm going to show now is about finding files for a specific vehicle. So you will see the query is pre-populated for a specific vehicle, which is the latest Range Rover Evoque that we are releasing this year, so 16 model year. We are going to try and find tests for high speed, because I know that here in Texas you love driving fast. So I'm going to set vehicle speed to at least 155 kph, which is around 95 miles per hour. Hit the run button, and we get a list with multiple files and their metadata. Note that this search that has taken maybe 1 second has been searching on a database with around 400,000 files.
So that was a really fast turnaround time to get such specific results from so many files. But now that we have these files that require additional analysis, what's the next steps?
So from here, engineer can run their own analysis routine. We can run the analysis on a specific set of files, or we can just send an analysis request to our server and batch process potentially thousands of files. Once the analysis is complete, we will receive a comprehensive report that we can use to iterate our designs and to make decisions faster.
Awesome. So Pablo, what results have you seen based on your work?
Yeah, so I'm happy to say that within the 1 year we have spent implementing and developing this solution, we are now analyzing more than 95% of the data that we collect. Not only that, but the number of tests and the cost of this is lower, because now we don't need to rerun any tests as we were doing before.
So you went from analyzing less than 10% to over 95% of your data because you implemented a data management and analysis solution based on DNM and Data Finder Server Edition.
Yes, exactly. And not only that, but the number of tests, and especially the, how to say it? Yeah, the number of tests is lower and our products are more robust, because now we are detecting more issues up front before we pass our final product to our customer. So our customer satisfaction rating is higher because our products are better than before.
So that truly is an amazing application that has benefited from 30 years of investment in NI's technical data management platform. With that being said, I'm happy to announce the release of DDEM 2015 and Data Finder Server 2015 to help you all make data-driven decisions faster.
Awesome. So congratulations, Stephanie, on those software releases. And Pablo, thanks so much for joining us today to show us how you solved the big analog data challenge. Thanks, Phil.
I think it's gone.
So I hope that gives you an idea of how you're able to use data with DDEM and Data Finder Server. The other thing that we wanted to show you, obviously that's a great case study from the UK. The second one is another fantastic case study from the UK by David Lyons from Diagnostic Sonar up in Scotland. It's a bit of a shorter video, thankfully, but Maria's just going to put that one on now. This is mobile.
All right, another trend that's driving the industrial Internet of Things is advanced sensing. Scientists and engineers are doing big analog data analytics in the cloud and at the edge with the LabVIEW architecture. Scientists and engineers designing things like radar systems, particle accelerators, and advanced imaging systems. To learn more about those, let's welcome to the stage Jeff Bergeron from National Instruments and David Lyons from Diagnostic Sonar.
Hey, David.
Hi, Jamie.
Good to see you.
Good to see you.
Good to see you, Jeff. Now, David, this isn't the first time that diagnostic sonar has been represented on the keynote stage. We've been working together for some time, but why don't you remind everyone what it is your company does?
Thanks, Jamie. Yes, Diagnostic Sonar has been doing medical and industrial ultrasound imaging for many years, and we've been using the FlexRio platform. Indeed, the first time that this technology was demonstrated was 5 years ago at NI Week. Now, one of the things that everyone will be able to appreciate is that medical and industrial imaging are very different beasts. But one of the key things is that with the FlexRio architecture and the Rio architecture, we're able to use the same thing for both.
Right, so you do everything from living things all the way to composite materials with this imaging system, is that right?
Exactly, and we use the same hardware for both.
Excellent. Now, one application where you've had a great deal of success is imaging composites that are used in airplanes. Can we talk more about that?
That's right. Airplanes are now being made of composites in order to be able to keep the fuel efficiency because of the lighter weight. However, they pose different challenges for the inspection. As an example, if you have a bird strike in flight, or when if a gateway ramp is driven into the side of the aircraft, it may need to be checked out before the aircraft is okay to fly again. Now, at the moment, this is being done with small portable instrumentation, but it's difficult to analyze the data, and it requires an experienced operator.
And that's one of the things that we've been working on together is actually putting together some technology so you can have a more portable solution for these applications.
Exactly. You need small size, high speed, high performance, and we've got the high performance in our PXI system. We need the portability to be able to take it out to the aircraft.
Well, Dave, how about we show everybody here what we've been working on together?
Sounds good.
Today, we're happy to announce another product built on the LabVIEW Rio architecture, the controller for FlexRio. This is a standalone device. This is a standalone device with a huge Kintex 7 FPGA for signal processing, high-speed serial technology for data streaming, and an embedded processor for deployed operation. The device also supports our FlexRio adapter modules, bringing high-performance I/O to this compact form factor.
Excellent. So, David, is this technology going to give you what you need?
It certainly is, and because it's using the same hardware, it basically means that our software, we can reuse it straight from our PXI system straight to this with almost no modifications.
Right, so you brought a demonstration here today that you want to show everybody, is that right?
That's correct. What we have here is a carbon fiber composite panel. No external damage is visible at all on this. However, as we scan it back and forwards along here, we can see some features on that internally, but they're difficult to understand. So one of the key things that what we really want to be able to do is to be able to create a map of that. Wow. And what I hope people will be able to understand is even if you don't know ultrasound, that's a great deal easier to see and size the defect, make an assessment as to whether the aircraft is in a go, no-go position. It saves you being on the tarmac eating your peanuts.
Yeah, that's great. Get us back in the air. Now, the thing that it's not quite apparent is there's no visual damage on this piece of composite at all. It's all underneath the surface. And you're bringing in 3.2 gigabytes of data a second, processing that in the FPGA, and then pushing these real-time images up for an expert user to take a look at, not only right there by the airplane, but they can look at it from anywhere in the world. That's pretty amazing. Thanks a lot, Dave. Thank you. Jeff, awesome work. It's great working with you guys. Can't wait for the next invention.
Hey guys, thanks for watching that. If you want to see any of the other NI Week keynote speeches, they're on ni.com/NI Week, and there are some fantastic ones. Obviously, a good one to watch is the morning keynote from Dr. Truchard himself, and he explains a lot of the work we're doing in big analog data and also how we're approaching the Internet of Things as well. I'm going to hand over to Maria, who's going to give you a technology update. So here we go.
That's all right. Okay, so just looking at the main themes from NI Week this year, of course, as always at NI, we want to equip engineers and scientists like yourselves with the technology you need to make to solve the next grand engineering challenges. And also from an academic perspective, we need to inspire future innovators and give them the tools they need to kind of understand engineering and science better. can we just, is everyone, there's no one on the phone who's an academic kind of customer, would that be right?
Yeah.
Right. Okay, so I'm just going to leave out the academic portion because we are a bit stuck for time. But if anyone needs any further information, just contact us, and of course we'll be happy to send that through to you. Okay, so we're going to start off with software and work through the rest. So I'm kind of going to start with just looking at the main reasons for upgrading. So the main reason why our customers upgrade is for new features and the latest hardware support. And also, if you're starting a new project, users prefer to use the latest version of LabVIEW because it kind of gives you the longest lifespan going into the future. Most of our users upgrade within 1 to 3 years, and also many of our developers use multiple versions of LabVIEW. So if you keep up with your SSP, of course, you can download any previous version of LabVIEW if you want to do a particular project in a particular version. So the highlights for LabVIEW 2015, the 3 main themes are writing code faster, writing faster code, and also additional features for customer success. So in terms of writing code faster, I'm just going to show you the additional features that have been added for this. Hopefully it'll be a bit more interesting. So let me see. The first thing I'll kind of draw your attention to is the help file in this. So when you first open LabVIEW 2015, there's a link to what's new. And if you just flick through that file, it'll show you everything and exactly how to do it. And one thing I'll point out that one of my customers quite interested in recently was the changes to the actor framework, which I may have gone past. Was it further up? Okay. Yeah. So yeah, there's a whole section here. If you use the actor framework, this might be interesting to you, but it's not something I'm going to cover today. I'm quite sure I'm not bothered with the actor framework today. So yeah, I've only got a kind of limited time, so check this out at your leisure. Yeah, that's the reason. Okay, so I've done a really simple VI just to kind of show the different changes that we've got. So just looking at this one first, I'm just generating a random number and displaying it in a numeric indicator. But say if I want to, oh, sorry. Hello. Why is my control space not working? Okay, we're going to have to do it the old way. If I drop down a for loop and then turn indexing on here, obviously we get a broken run arrow because we've got an array of data coming out. Now we've got a new shortcut function. I can just change to array. Boom. How cool is that? So that's pretty good. And then if you change your mind again, so if I just remove this for loop, obviously you get a broken run arrow, and you can do the same in the front panel. Just right click, change to element, and then when I go back, it's all sorted. So that's pretty handy. Let's delete it.
So both of those options available on the front panel and the block diagram?
Yes, so available both the front panel and the block diagram. Another new feature is the Explore shortcut. So I've got a really naughty sub-VI here because I haven't changed the icon. If you right click and go to Explore, it takes you to the location where that is stored. So that's pretty handy if you've got a lot of sub-VIs and don't know where on earth you save them. Similarly, we've got remove and rewire and wire all terminals. So if I click on this, I can create and do all controls and indicators, and it'll just add controls and indicators. Some people who are good with their shortcuts will know that this was already a shortcut, but you had to do control space and then control R or control D. Control D. So yeah, the shortcut menu is a little bit handier. And then if we just wire this up as well, then you can just right click and choose remove and rewire, and it does it for you. So this is all under the kind of making it faster to write your code. And yeah, let's get rid of this. And then scrolling down, this is one of my favorite ones now. If you hold down control and just click and drag, more space. So that's pretty cool. You can go in all directions if you find you need a bit more space in a certain part of your block diagram. And equally well, if you need to kind of reduce the space, Control plus Alt will let you just drag it in. like that. So yeah, really nice feature. At NI Week, that got a bit of an applause and some whoops from the American audience, but we're much more reserved here. Okay, then looking at arrays. So I've got a 3x3 array here. If I just add something else in here, so you can see it's now 4x3, we can just right click, data operations, and transpose array, and it switches it. So you can transpose 2D arrays with a right click option. Also, say if I make this number, say 5, and I'll put like 6 zeros after it, from here, that looks like 5,000, which isn't ideal. So just to further kind of increase visibility, you can just go to right click and size to widest element, and it sizes the array out to the widest element, which is pretty handy. So the best thing about all these items in the shortcut menus is that it's written in LabVIEW. So if I right click again, you can see there's some strange things going on in here. So this is me having a mess around. And the way that you create these, you just go to this location. Okay, I'll just bring it up. You can see. And create shortcut menu plugin from template. And then you just specify the name of a plugin, whatever you want, and run it. And it brings you up all the different controls you need. So you can just make changes to the type def and add another item to your shortcut menu. So that's pretty cool as well. And now if we go back to the slides. So yeah, can I nick that? Make it slightly more interesting, maybe looking at the book. So this is obviously all under the write code faster section, but also we want you to be able to write faster code. So it's an 8 times faster load time for your big, large package project libraries. And we've got a big R&D effort called LabVIEW Without Limits to improve code performance and memory usage. So I think it can be quite easy to focus on the new features and kind of forget about the stuff going on in the background, which is arguably more impressive and more useful. And the one that I really like is you can now open your code without that annoying search for all the things you've forgotten to install. So you're missing sub VIs and uninstalled modules or toolkits. Now you have that little pop up and it scrolls across for ages, so you can do that without searching for those now, which is pretty handy. And then under the additional features for customer success, these kind of come under our new LabVIEW suites. So some of you will have heard of these already. So it's LabVIEW professional software, but then we add various toolkits on. So we've got 3 of them. We've got a test suite, communications, and embedded. And so, for example, the test suite comes with LabVIEW and test and a range of other things. Embedded has the FPGA toolkit, real time, and some other add-ons. And yeah, so now it comes as one package. And the most amazing thing about this is that it now comes with a 1-year training and certification membership. So you can literally sit, I'm going to say unlimited training. Is it limited? It is unlimited, yeah. And unlimited certification, so you can do all your exams as well. So that's really good if anyone is kind of looking for a new license, or maybe you've got a new employee and you want to get them set up on it. That's pretty useful. And yeah, they now come on USBs, which is even better. You don't have a big pack of disks to worry about. Again, nothing's really changed edition-wise from the previous year, so I'm just going to skip past that. And this is quite cool for any of us closeted nerds. There's now a LabVIEW home bundle, so you can pay the equivalent of $49 to have your kind of LabVIEW home version. For anyone who's an ex-student, it's similar to the student version. And yeah, you get kind of everything you would really need to geek out on your own projects. But it does have a watermark on it. So whenever you invent something that's going to make you a fortune, you do need to start paying us for the software. But yeah, so that's pretty cool. We always call out something new on the LabVIEW Tools Network at NI Week. So this year it was SignalPad from Kiko Tech. So it's data logging and analysis software for sound and vibration, and written by some former NI developers. So it's very configuration based. So for users who don't want to build up the LabVIEW VIs themselves, and of course, very seamless integration with NI hardware, and that's available from the Tools network. So Data Finder Server Edition was called out in that Jaguar Land Rover case study, so I'll not go into it too much. There's just quite a good couple of diagrams here which show how it works. And yeah, we've just had the 2015 release in August. So customers I've seen using this are people who store a lot of data but need distributed members of their team to access it. That's quite a big application. And so yeah, very fast indexing and search performance on this. And that links obviously closely with DNM 2015. So we've now got 64-bit DNM, which is pretty cool, and a load of features here that I'm not going to go through now. It's all on the website. Okay, now we're on to hardware, and this is going to be a bit like new product roulette because we are stuck for time. So yeah, just shout if you want me to stop on something, or if you're using one of these new pieces of hardware and want to kind of share something with the group, that would be pretty good. So yeah, we've got our new CDAC controllers. So we've got quad core processors in here, so 4 and 8 slot versions. So yeah, higher performance in a smaller and more rugged form factor for compact DAC. And also the 14 slot USB 3 chassis, which is really cool. So we just add on all this extra space for people who need a lot of different signal conditioning systems in there. And so I think the real strength of compact DAC now is that people can do the kind of distributed applications, but if they don't need that real-time determinism, then there's not like kind of the same complexities in the code as there is using compact real. So I think this is going to be pretty popular. And again, we've got obviously the higher data throughput to cope with the extra slots as well. So you can get 250 megabytes per second with that USB 3.0 support. Yeah, this one I decided to, so there's a lot of new C-series modules, and I've just picked a couple. I decided to keep this one in because it's a low-cost condition monitoring analog input module. And from what I've seen, condition monitoring is an industry area that's just going to grow and grow. Everyone is doing predictive and preventative maintenance now, not just in like the kind of, I guess, like energy industry where you've got big factories, but also things like automotive. A lot of people are doing it as well. And so yeah, I just wanted to kind of call it out, but of course download the data sheet if it's something you're interested in. This one here I wanted to call it as well. So it's a universal C-series module. I think this is really cool. So you can measure voltage, current, your bridge stuff, accelerometers, amplified sensors, all with this one module. So if you're developing projects for a customer, then you can get quite a lot going on in a small form factor. And yeah, this, speaking of condition monitoring, it kind of brings us on to Insight CM. So I don't know have you seen much Insight CM stuff? Have you done any lead users?
Yeah, one of our guys is trained up in your Paris training course. So we've used it a little bit, not much.
So it's very new, and it's vital that we kind of get as much feedback as possible on this, in my opinion, because it's a really cool bit of software. But yeah, it's quite specific, I guess, to where it's being used. So the customer examples who have used it so far. So yeah, we've now got a new evaluation version, which gets you the evaluation software for 4 months, which is pretty good, and also the compatible hardware. So you get your chassis, controller, and the acquisition modules that you'll need. So yeah, I think this is going to be a really good product for us in the future, as it really helps kind of manage all of your distributed sensing. Okay, and that brings us on to embedded. So new performance compact radio, as always, we're just upping and upping the performance in these. So we've got a quad-core Intel Atom processor on these, and the Kintex 7 FPGAs, and 16 DMA FIFO channels. And then similarly, single board radio, we've just upped the throughput and performance again. Have you done much with single board radio? Yeah. They're pretty cool.
Yeah, awesome.
Yeah. So this just for anyone kind of who's not as familiar, you can start off on compact radio, but for some of your customers, this might only be good enough for a prototype, and they might want to go down into a smaller form factor where size, weight, and power are a bigger consideration. So that's where a single board radio can come in, and then you can go down to system on module, which is kind of credit card sized if you so wish. Okay, so that takes us on to the next one, which is this expandable direct injector driver system. And if anyone has any questions about this, I'm going straight to Chris. So yeah, it's 9882 based. It comes as a whole system with some extra slots if you want to add any kind of specific functionality. And coming in the enclosure system is a kind of optional part of it. Is there anything you want to add on this one, Chris? Sorry, I picked the worst time. He's just put a biscuit in his mouth.
Purposely done.
Yeah.
This area is a market where R&D investment for us at the moment. There are going to be other products that follow this, which should definitely add to that portfolio. So if that is an area that you are looking into and you want to have competition with someone, there's probably things that we can say behind closed doors that might be of interest to you. So
yeah, that's very good points. Yeah, just give Chris a shout on this. And I know that we've got various experts kind of in Europe that'll be in the UK soon as well. So even if you're thinking about this further down the line, reach out to Chris now on it so we can kind of put things in place to help you. And yeah, there's now this powertrain control module for compact rail as well, which I thought a few people might be interested with VR and Hall effect sensor inputs. And yes, the controller for flex rail. So it kind of, I was really excited about this, but I'm not going to come across with the same enthusiasm as the guy in the video, kind of holding it up like a trophy. But yeah, you can see here the flex rail modules, and then they just slot nicely into the controller around the back here. So these are really cool. Again, it allows you, if you're doing a kind of more deployed solution, then they're optimized for size, weight, and power again. So yeah, big fan of this one. Okay, that brings us on to test, making good progress. I hope people can understand me. And yeah, this brings us on to the our latest embedded controller, which is the 8880. It's incredibly hard to say in a Northern Irish accent. And yeah, this is the highest PXIe performance and throughput we've seen to date. So Intel Xeon processor and 24 gigabytes per second of bandwidth. So pretty meaty. I was out with a customer yesterday who are currently using it, and yeah, they absolutely love the performance of it. Yeah, it's awesome. And yeah, another one then, high voltage source measurement unit. So we're going up to 200 volts on this one. Very high precision, very high speed if this is something you need. And yeah, I thought I'd call out the RF multiplexer switch modules, again, just because I spoke to someone recently that didn't realize we did them. So yeah, double the density of existing NI modules, and there's a whole wealth of RF information on our website. If that's one of your application areas, definitely give us a shout on that. And yeah, mine and Chris's boss is the area sales manager, and his background is very heavily RF. So please reach out to us if you have any RF projects. And on that, in that kind of similar ilk, we've got the wireless test system as well, which some people may not be that familiar with. So yeah, these are controlled by Skippy over Ethernet. And yeah, you can use kind of a built-in clock reference or have an external one. And there's a whole wealth of stuff on our website for this too. Yeah, RFMX, so in the software side, you'll have seen RFMX before probably, so it's like DAC-MX, but for RF, and every bit is easy, you don't need to be scared of RF. And now with the latest version, you can perform cellular measurements from GSM to LTE Advanced, so that wasn't included in the last version. And so that's pretty cool, and of course you've got the soft panel debugging as well, which can be pretty helpful. And that takes us on to academic, which I'm going to skip over because there's no one here. But there's some pretty cool stuff in there. If you know anyone who's looking at academic applications, get them to give us a shout. And finally, I just wanted to kind of do a brief note on services. So this is a slide that people have seen before. But I love it. It's one of my kind of favorite slides that we have. So once you kind of choose, okay, I need a certain specification of hardware and software, there you're at the NI products level. On top of that, you need to then get trained, and you might need certain calibration, especially if you're in an industry like aerospace and defense. You'll need maintenance and perhaps really long lifespan. So that's where our services come in. And then at the top, I really like this because it kind of shows the relationship between your team and then a partner such as Austin Consultants. So you might choose to do all of it yourself, all of the hardware and software, or you might want a fully turnkey solution. And you will kind of balance how much of this you want to do yourself and how much you want to use a partner for. So whether you want them to provide you a full integrated solution or just to come in and help you for a couple of days, just remember that they are there and don't suffer in silence. So all of this kind of makes up the eventual solution you'll come to, along with, of course, our community, so user groups like this, and also the IP that's on the website and different add-ons as well. And so I think it's just important to remember not just to focus on the products and the specifications, but how you're going to bring the solution together. And that is it. I suppose oh, no, it's not. The main bit of services, yeah, this new course, which I think a lot of you will be aware of already, but I'll just give it another plug. So the Embedded Control and Monitoring using LabVIEW course. For any old school people, it's FPGA real-time 1 and real-time 2, except instead of 7 days, it's 5 days. So there's a bit of duplication in those courses, so we kind of cut it down, and you build a kind of compact real project from requirements gathering through to deployment in 1 week. And it fully prepares you for the Certified LabVIEW Embedded Systems Developer exam, or CLD, which so you said some people have done it. Yeah, so I think it's pretty tough. We've had a few people do it, but yeah, absolutely great thing to do if you're going to be designing embedded systems. And so yeah, any more information needed on that, just give us a shout, and that is the end. Okay, thank you for listening. I tried to do it as quickly as possible.
Good stuff. I think my agenda memory fits me well, both. Yeah, just gonna get up camera going
Do you want to do it on my laptop?
Yeah. Is that PC, right?
Yeah.
Okay, cool. Shall I stand in the front?
You can, but yeah. Yeah, it's both that.
Oh yeah.
Hi everyone, so I'm Bofu from Austin Consultants, and today I'm going to talk about the hidden Markov model in LabVIEW. So firstly, the outlines I'm going to talk through. Firstly, what is hidden Markov model and how to build one yourself, and like the implementation of hidden Markov model in LabVIEW. So what is hidden Markov model? According to Wikipedia, it's a statistic Markov model in which the system being modeled is assumed to be a Markov process with unobserved states, i.e. hidden states. So it is basically, it's a Markov model, but hidden. That's why I put in this picture. But so a Markov model is, you can imagine it as a state machine, but the way to transfer to the next state is not depends on the action you perceive, but it's in a probability, and there is a assumption that the probability goes to the next state is purely on its previous state or states. So in a very extreme simple case, we just assume the next state, the probability going to the next state is depending on the previous one state. That is called a one-order Markov model. And so, assuming, say you have 3 dice, and you pick up. So you have different dice. So for this one, you've got 6 faces, and 4 and 8. You're picking up different one, and the way you pick up the next one is depending on what the current one you're using, and like the probability might totally according to different people got different habits. And now assume that you can't see what die you picked up, but you can only see the number. Like after you throw it, the number that fits in the top. So in this case, for the first die, you can see 1 to 6, and 1 to 4, and 1 to 8. So there are 2 assumptions. One is the next state is determined by the previous state, and the next one is all the visible states is determined on the hidden states, i.e., like the probability you've seen 1 is 1/6 if you're using the first die, and 1/4 if you're using the second die. So if we draw it in a sort of state machine way, we've got 3 die. And well, I didn't draw all of them, but 8 numbers, and you've got different probabilities, go from one hidden state to the visible state, and also different probabilities go to the next state. So what's the use of this complex model? Well, it's widely used in speech recognition and written recognition. So for example, when you hear something, when you hear people saying a sentence, the way you want to like transmit that to text, the signal you have got is analog signal, is waveforms, and you chop that into different words. But probably people just say it slightly differently for the same word, and the way the different words combine are following some probability. So you can't really see what they are saying because you don't see the text, but you can hear the visible state, i.e. the sound. So considering like there, like when you say there can be 2 words. It's over there as it's their product, and it's according to what they said previously that you give you the information of what that is. And another, and also like writing, because people can just write. If you just look at a single letter, it can look like everything, like S or 5. But it's also like using the previous letters to determine what the next one is. And bioinformatics. In some applications, there are people try to sequence the genes. So the genes are following to the previous genes under different probabilities, and you can't really see the genes, but you can see the pretend they express. So to turn this model into a mathematical model, firstly, we need a transition matrix, i.e. the probability to transfer from one hidden state to the next hidden state. Take the weather, for example. Say today is raining, and the probability for it to maintain raining the next day, say it's 0.3, and it is sunny, and it's 70% to be sunny the next day. And if today is sunny, you've got different probability as well. We can turn this to a table. So you've got current state and the next state. So you've got a matrix here. We call this transition matrix. And the emission matrix is this one. So the probability from one hidden state to different visible states. So in this case, everyone is 1/6 and 0 for 7 and 8. So 1/4 for 1 to 4 and 0 for the rest. So 1/8 for all of the numbers. So back to the weather example. So say if we put a seaweed, say if we can't really see what's the weather like outside, but instead we put a seaweed, then the seaweed might be dry. Well, there's 10%. It is dry when it's raining, and 0.3 is soggy, 0.6 when it's ringing. You got another matrix, we call this emission matrix. Also, to enter into the state machine, there is an initial state. So that one is called initial state. We use pi to stand for that. So for one hidden Markov model parameter, you need 3 metrics. Or the last one is a vector really. So transition matrix, emission matrix, and initial state. Now, how to build one hidden Markov model? For a hidden Markov model, you're always trying to solve three kinds of questions. One is valuation, decoding, and last one is learning. So what are they? Evaluation, say, so you have the dice, and you just throw different dice, a lot of times, and you observe the numbers. So you got a sequence of numbers, and you want to figure out the probability of that one, or the probability of the next number. And in a real case, this is used to evaluate like which module you took use of. Because, for example, I just follow my own habit to pick up different dice, and another person might just follow different probability. So rather than you can really see which dice the person is using, you just observe the sequence of numbers. You can predict like which one behind it was really throwing the dice. So in a mathematical way, it's given the model, so you know the probability of everything, and you can see the visible states. Now try to figure out the probability. This is solved by using forward-backward algorithm. I will just give you a very brief explanation of that. So to figure out the probabilities, since we got the matrix, so we can just try to basically do the multiplication. Basically, it's A multiplied by B for state 1, and multiplied by A2 multiplied by B2. It's really like following different paths. Say you got state 1, so you got visible state 1 to T. Now you are trying to figure out, calculate all the probability or all the paths allows you to go from the initial state to the last state, and then you sum up all the probability. That is a naive way of doing this, but considering the computation power, it's a lot. So, because in real case, you always like easily get thousands of sequence. So it's a very long sequence, and if you want to do you got like 3 different combinations multiplied by 3 by 3 by 3. So it's just a lot of computation. Okay. So instead of doing that, we do the sum of the previous states. So rather than every time you're calculating a new routine, you can assume, say, that is the last one, you calculate the previous one or the previous 2, then for the next one, you just start from this. So it's doing it in an iterative way. So you can do this in a forward way. So you start from the initial state and calculate the probability, go to the next state, and also multiply it by the probability of showing a particular visible state. You do the sum, and then you store the number or store the values in the temporal variables. Next time when you calculate the next state, you just start from this one. The next question is decoding. So now you got the model, and you have seen the visible states. So what really happened? What happened underneath? So back to that dice problem is, so which die you picked up every time? Which is most likely die you picked up? This, when you are figuring out the speech recognition one, is so which word you're really saying. we heard the sound, we heard the sound wave, but which word you're saying underneath? That's the problem you will try to figure out. Again, so that is back to the path problem. It's trying to figure out a path, give you the most probability. So to start from the initial state and end at the very last state, you try to figure out the path with the maximum probability. That is an NP problem. You have to figure out all the probabilities and to find out the biggest one. So again, that is hard. Another way to address this is if one path was optimized and it say go past ST, so some state in the middle, all the rest are optimized as well. So say that is the final state, and if it is the optimized path went past this one, all the rest have to follow the best one. So, otherwise, there will be a better path. Then that is not the optimized node you pass through. Is that intuitive? Well, that allows us to say, so from the beginning, we are always trying to find out the path, the node that gives us the best probability.
You get messed up a bit if, say, somebody has used the wrong terminology for like the word there, for example.
Yep.
So you're trying to get the best probability, so but you would possibly still lose what their meaning was when you did it, or
you
full state there.
So if you want to figure out what their word really is, you try to so you have the previous hidden market model, i.e. the probability to connect one word to another, and then the previous one, if it is they, there might also be different words of they, but one can be really they are. So they, why they? Sorry. It is. Say it is. It is. And then you are after basically it's figure out is gives you more information to figure out what the next one, what the next word is.
So does that make sense? Is it trying to pre-guess what the next word would be?
That's one way. You can pre-guess it, but also it's given you heard the sound there.
Yeah.
You try to write it down. What that word really is. Is that there, or is here and there?
So, in terms of the hidden part of the kind of market model, would a normal market model you just have the information for like what part would be the hidden in a sentence?
The really meaning is the sentence, or if you write down each word, if you write down the words are the hidden states. But we are saying that there's no subtitle, so you don't know what you're really saying. Like what you're really saying. Yeah. So I just hear the sound is the visible states.
Okay.
Okay. So I'll try to recap a bit. So the previous, so back to this is, if you say a long sentence, what's the probability? Well, what's the probability of that sentence could be?
So you're saying the longer the sentence is, the higher the probability that you get that right.
The more previous information you got.
Yeah.
Yeah. So say the current word. Well, for this model, for the current word, the very first word you said doesn't really give the information of the very last word, but it can give you more information of the second word, so which just pass through, and so you can be more confirmed on the previous one. So now you see what we're saying for the last one.
So if you say it was a word there and you had like the previous word was over there.
Yeah.
So then that could still be either. If you had the whole sentence, so we are going over there, is it's much more likely that it's THGRE, but it could still be like we are going over their heads instead of THGs. But the probability is that it's ERE, not EIR.
Yeah.
The longer the settings, the more likely you're
yeah, that's true.
But then, are you kind of talking about the actual way you say it, like the way you say the word as well? Does that hidden then? So the actual like intonation or
the actual things you're saying is the hidden states. So like basically what's in your mind is the hidden states. What I got is the visible states.
Yeah.
Or the
the
sound.
Yeah. It's really interesting. That's what I'm asking.
But I think it would take inflection into account.
It should do if it's just sound, isn't it? Yeah.
If you take inflection into account, but the spelling part is much more difficult because often when you do audio analysis, you break it down into phonetic sounds and then you use those to make up the words. Yeah, if a word with different spellings have the same phonetic pronunciation, you have to use a different system.
That's what I was saying before about actually the difference if you're writing it as opposed to speaking it, because maybe when you're writing it, you actually get it wrong. So you've actually now given it an incorrect thing because your English isn't very good.
Actually, because that's exactly the example. So in this evaluation, say if you spelled something wrong, and according to the hidden Markov model you got previously, you got like very small chance to write that way. So you can just promote, did you write it wrong?
So with that, Microsoft Word, for example, going and doing a spell check, is that as clever enough as, is that how they do it? Or what's their kind of, I can imagine not. But.
I can't see that for sure, but I'd say more than 80% of all the like speech recognition and writing recognition are based on this.
Cool.
So very likely that you're using one. But also, they try to do a lot of pre-processing. So, for example, the voice recognition, you don't just feed the system with the voice, but you do pre-processing so for example, chop every one word to different like vowels.
Yeah.
And like do some abstraction of that, take out features, then you feed this model.
That makes sense.
I think there's definitely something similar to this, guess what I think the next one is.
Yeah.
Right, I can just go, yeah. It's like about 10 words down the road. And it's like, yeah, I didn't know that.
That's quite cool.
Yeah, I guess so. Well, this is really like techie details, so I don't have to go to the very details, but basically the fact that you can, to find out the best way, you don't have to calculate all the paths, and instead you can just calculate the path. So if you go it from backwards, you just always calculate the path that gives you the best probability by buffering all the rest information. That is just similar to the previous question. So instead we buffer the sum of the previous states here, we buffer the maximized value here. That just gives you the right path. Again, it's detailed problem. So we are calculating the probability is always less than 1, and because you are calculating like thousands or 10,000s of words, so that just decreases exponentially, and the float just can't hold that. So instead we calculate the multiplication, we calculate the logarithm. The very last question is learning, because in many situations you don't really have the hidden Markov model. That is very abstract problems. So you are trying to build your own hidden Markov model. If I still use a dice problem to do the analogy, is you don't know like what's the probability for me to pick up the next die, because I don't know that. There's no such a number. But I can just throw the die and pick the die like thousands of times and record it, build up one model that might fit me, and say Pete throw the die again, and build a model for him. So the next time when we see a sequence, we can figure out which model just fits that the best. There might not be a perfect model, but as long as it can tell one from the other, that is good enough. Yeah, so this will be basically in mathematical way, it's more complicated. We are doing that in using expectation maximization algorithm. So basically, you don't have the parameters in the model. You start by some random initial numbers. You feed the model. You do the evaluation. You calculate the error, and then you update the parameters to try to achieve the best one. And it's only stop when it converges. So if you're interested, so the name of the algorithm is called Bob Welch. Yeah, I thought I read that.
So the book okay, I'd like to get on clever enough. It looks like a Bob Welch.
So Bob Welch algorithm, and it's one kind of expectation maximization algorithm. So that is two parameters you involved. That is not the hidden Markov model, but it's like the buffer parameters you used well, this one is to compute the probability to go past one state. So what's the probability you can go past this state? And this is, well, given this state and that state, what's the probability you can go like past that two states? And then you try to maximize that numbers iteratively. Yeah, so that was the mathematical way of explaining the hidden Markov model. And why are we building that in LabVIEW? Well, there are a lot of libraries there already for hidden Markov model in R, Python, C, C++, Java, MATLAB, and so on. I haven't seen one in LabVIEW, and since people are using LabVIEW for different cases, sometimes you don't want really like mix the language if you don't have to. So besides building some other machine learning toolkits, I found this one might be useful, and yeah, and when I Googled it, also someone in my forum asking if there is such a toolkit. Yeah, so the way I built that, I didn't use third-party add-ons in LabVIEW. So you install LabVIEW, and that's all you need. You don't need to download some other add-ons to do that. I put in the equations, so in case you want to check the implementation or you want to do the coding in a more effective way, there are materials there. So I created a LabVIEW library, and here you can see that is the API. So that is the method you're calling to address that three problems. So there is forward and backwards algorithm to solve the evaluation problem, and the V2B algorithm to solve the decoding problem, and the Baum-Welch algorithm to solve the learning problem. And there are also sub-VIs, so all the details are wrapped in the sub-VIs. It's not exposed, but if you are interested, you can look into it. And I also created some demos for the method, so you can try compare the method with whether some previous result you got or with your own method. And that is a front panel of one demo. I will go to more details for the next slides. So that is the example of Baum-Welch algorithm. So the detailed algorithm is wrapped up and documented if you want to dig into it, the equations are there, and you can check that and try to, probably there is a better way to like compute the multiplication of 2D array and 1D array. You can always try to optimize that. Now is a demo. I try to find out a more intuitive way to demonstrate this, but yeah, let's see. So the input is one paragraph, or there are about 5,000 words, 5,000 letters in that paragraph. I just took it randomly from online. And that is the statistic of the letters. 0 is space and start from A to Z. So you can see some of the letters just occur more frequently than the others. And if we feed that, so now we don't have a hidden Markov model. We don't know how letters are connected to each other. So we don't have that prior knowledge. And we just define the hidden Markov model, say there might be 2 hidden states. And we can see the letters, but can you just sort it to 2 states, 2 hidden states? So initially, we tell there are 2 states. So one state so is the red dot, another is the blue lines. And we just initialize them evenly. It's not really 1/27. There's slightly a small randomness which you can't really see.
So what do you mean by this? So in this example, the 2 states would be what? Which letter comes before the next letter? Or
no, say we just assume there are 2 states that some of the letters more likely to belong to this state.
So in terms of state, it's part of the word, or?
One group.
So paragraph group, wording group.
You won't see paragraph. It will only see the letters.
Yeah.
So
group will be a word.
No, 2 groups. Actually, these answers are on the next slide. So, but we say there are. But yeah, assume that you don't know English. You don't know, or that is not English, and you've just seen a lot of symbols. And firstly, you want just to try to sort it to different ones. Say that this one or this are more meaningful to each other, or they are more related to each other, and if the other one appears, it more likely to belong to the other group. So that's like the way you analyze something. You have no prior knowledge. Yeah. So after we do the hidden Markov model, and that is emission matrix. So that is, say we have 2. That is like 2 dies, right? So for 1 die, it's more like to have some. Sorry, are you?
Yeah, bro. I was wondering, are you just sorting the vowels from the consonants? Basically, one group of letters is the vowels, which are more frequent, and then the other group turns out to be the consonants, which are less frequent. Is that what happens there? The red dots are the vowels?
You just give up. You just gave away the best bit. Yeah. I mean to say, ta-da.
That was well explained.
Yeah, so I suppose like what makes it is that so each one knows the letter, what's the next or nearest letter to it in each time. So in a word, you kind of have a vowel next to a consonant, which is kind of like.
Yeah, so Patrick, yeah, exactly. So these red dots are A, E, I, O, U, and the blue lines are the consonants.
This should define the Scrabble board really in the point system.
Oh yes, definitely. Yeah.
And also, if we go back and see that A, E, I, like I, O, U. Okay, A, E, I, O, U. Well, they don't really just stand out right there, right? Something like, which is this one? T. Well, yes, some methods. and two of these, right? They're just more. They appear more frequent than the others, like S and T. They appear very frequent. So. Yeah, so they don't just do that according to statistically, but like the relationship between the letters, and it just come out to be the vowels and the consonants. Yeah, so now we have the vowels and the consonants. So imagine that is another unknown language, and you're trying to figure out like that is like very alien language or a very old language. You have no prior knowledge. Now you can tell that that kind of symbol belongs to vowel. If there is such a vowel, that is one thing. There's another thing. Yeah. So you can find this toolkit from Austin Consultants blog, or if you Google hidden Markov model LabVIEW. So the first result is from online forum, but the second result is the Austin Consultants blog. And yeah, your feedback is welcome, because at the moment the computation is not run like in a very effective way, and you are welcome to improve the speed. Yeah, thanks.
Yeah, I think it's quite an interesting one. Again, it's something that I kind of see this week. So, if you think about LabVIEW, people always think, yeah, integration with hardware, really obviously for LabVIEW is good. But where I find it challenging sometimes is if you've got people, say, their background is signal processing or designing, for example, communications algorithms. And I think that, again, is another real strength of LabVIEW, because it's easier to code in LabVIEW, I think, than start to learn a text-based language, which you just see the pictures of what you want to do. But it's always a bit of a challenging message, I think, to kind of put across. So yeah, I was speaking to someone who was like the head of signal processing, and it's like, oh no, I'd rather use the XYZ software. Like that's LabVIEW's for hardware, and it's like, well, no, it's not really. So it's cool having examples like this, where we can kind of say, no, you can use it for processing and for algorithm development, and in fact, it's a lot easier than.
This is funny you said. So we were literally in a conversation yesterday with a very top-notch computer scientist, like world-renowned, and his understanding of LabVIEW again was, no, that's for using hardware. I was like, no, it's a complete software language, and we've actually got all these tools and kind of things to put through. I think one of the reasons we were keen to write this in LabVIEW is actually, just to improve the community and improve the kind of awareness, I suppose, that actually these algorithms can be put through. I don't want to have to sit there and write that in MATLAB or pull it in, when actually we can sit and build it in LabVIEW.
I think these things make a lot more sense as a block diagram. Trying to explain these is that Bound-Welch equation. I did a lot of maths at university, and I can't look at that. And I actually did the Bound-Welch equation. I can't, you have to put it back together. But it's a diagram. It just kind of flow.
Yeah, and like you say, like everything, it kind of rolls off the tongue, like you say, like everything we do, it's like for engineers and scientists, and I think like scientist is like a kind of word to focus on. Some people are scared, like, oh, I've never programmed before, but everyone needs to program now. There's no two ways about it. You need to program to go with the speed that you want. Even in like lab experiments, like I know someone who's doing a thing with like testing on mice, and they have to automate how the mice move around because they physically don't have the time to move the mice themselves. Like that's the level of efficiency people need everywhere. And then I think people need to realize that it's not hard to kind of get going with LabVIEW. You don't need an engineering background or a computing background. If you're a really mathematical person, then just do your algorithms in LabVIEW. Yeah, it's good to have like an example that we can kind of fall back on now. Well done.
Do you see a lot of AI progressing in LabVIEW? Like, have you seen any kind of trend in this direction?
We've had a lot of people using things like the FPGA tools for neural mapping and things like that, neural network research. We've got a few case studies in the pipeline for that sort of thing.
We'd love to speak to those guys as well, because like I say, I'm quick to kind of build the community of the AI stuff, because we're going to go up to 4 AI guys in the team. And everyone's going to be LabVIEW as their kind of core skill.
I'll put you in touch with Rich Roberts, who's looking at the case studies, and he'll be able to give you all the contact.
That'd be really cool. 'Cause, yeah, we just don't want to keep rewriting stuff. Hence we thought we'd kind of go and have this. But that's probably about the fourth time Bo's explained that to me.
Getting there.
It's not easy to get your head around. Yeah. Cool. Okay. Should we pause this, grab a tea break, and chill for a bit?
I'm going to mute it. I won't pause it because it'll crash it, but I will be back to home. We'll be back in 10 minutes.
Okay, we are back. Thank you for your patience.
Okay, so next session. So anyone who doesn't know me, I briefly introduce myself at the end. I'm one of the applications engineering specialists in the UK branch. So I tend to work with pretty much any customers throughout the northern region of Europe, and tend to work on test-focused applications, doing LabVIEW, test and PXI, and trying to help them get the best out of the tools. So this presentation kind of came about because, well, partly because I really wanted to go to the CLA summit and I needed to make a presentation up, but also because I kind of got to a point in my LabVIEW development where I wanted to develop further and learn more tools, but found that I'd done kind of all the training courses. I'd passed the architect exam, and there isn't any more kind of official training at that point. So I started trying to read books and learn a bit more around general software engineering. So that's where I came across this idea of assertions. So I'll explain a little bit more in a second about what they are and where I came across them. But in terms of what I'm going to go through in this session, let's say what are assertions, when, how to use them, and when not to use them. And then I've built up a toolkit in LabVIEW to try and help enable them. And so I'll give a quick demo of that, and then just show you where you can get the toolkit if you want to have a play around with it. So this book, Code Complete, it's by a guy called Steve McConnell, and it's kind of a software development Bible, I guess, in a lot of ways. When I gave this presentation in Rome at the CLA summit, I asked who in the room had read this book, and out of about, I think there's 112 architects in the room, probably half of them stuck their hand up and said they'd read this book. So it's kind of a very well-known and well-regarded book for good software development practices. The idea that I was kind of looking at with this was, well, one of the best explanations I've come across is if you've got a large application with lots of different processes, lots of different sub-VIs that you're developing separately, as you develop all of these sub-functions or sub-VIs in LabVIEW, the likelihood is that you'll develop a sub-VI, you'll test that sub-VI for certain functionality, and then you'll kind of basically decide that it's working to a set of specifications, and then you'll go away and develop other bits of the code, and you'll kind of forget about it. So if you put these assert value or assert bits of code within your application, then you can just leave them there, forget about them effectively, and basically say if this sub-VI continues to perform to the specification, then the asserts will never do anything. If, say, 2 or 3 months down the line after you've developed a piece of code, you find that one of those asserts fails, it's because your code has gone into some corner case that you hadn't taken account of, and therefore it will loudly assert and kind of flag up an error or a dialog box or write a report or something to tell you this piece of code is actually, it has a bug in it and you need to sort that out. One of the other big points about them is that asserts should be compiled out of the code for deployment. So once you have finished your application and you know that it works and that none of these asserts are triggering, you can then just compile them out of the code for deployment so that your code hopefully runs a little bit faster. So that's kind of quite a long-winded way of saying it. There's a good Wikipedia article on asserts or assertions, which basically gives that in a bit more of a concise manner. It says here that it typically causes the execution to abort. The consensus when I talked to the CLAs about this was that having the application aborting was maybe a bit drastic, and just writing a report or something saying where the asserts had failed was probably a bit more sort of conducive to good LabVIEW development and not just getting annoyed with the assertions and ditching them. So I've left the ability to abort the application on an assert if you want to, but most of the time you just do it just generates a report. So in terms of how to use them, the general rule, according to the book, is use error handling for conditions that you expect to occur, and assertions for conditions that should never occur. So the assertions are there for debugging and improving the code before deployment. So things like checking that the inputs and output parameters for a sub-VI are within expected ranges, a file is open or closed when a certain operation begins, file is read-only, write-only, lots of things like that, that if that case isn't true, then there's something wrong with the code rather than the user has done something wrong. Possibly more importantly, when not to use them is basically error handling. So if the user selects an invalid configuration file or tries to select an invalid hardware reference, that's the user's done something wrong, which potentially you could put some kind of safe or some code in the application to stop that happening, but essentially the user's done something wrong rather than there being a bug in your code. So that should be handled by general error handling, which should be in any good, well-written application anyway. So what I wanted to do was develop an API which allowed people to configure and build these assert functions and drop them into LabVIEW applications, and then as the application executes, it kind of logs all these asserts, and then if one of them fails, then it generates a report. So try not to jog this too much. So this VI that I've got in front of me here is what's called the do assert VI. So this is the actual VI that gets dropped down in the LabVIEW application in lots of different places to determine all the asserts. So the assertions, these two controls here are the kind of key to configuring an assertion. So we've got an assertion name, so you can have lots of different assertions with lots of different names, and then the assertion data. I've made that into a variant data type, so you can just wire any other data type into it, and you can basically reconfigure it to work with lots of different data types. So far, in terms of actually flagging up assertions, there's only a few data types that I've supported. So string, floating point doubles, I32s, and booleans. But if you wanted to sort of modify the toolkit so you had classes or I16s or I64s, then it's not a big modification. It's just I couldn't take account of every single data type that could potentially be wired into it. This around the edge here, we've got a conditional disable structure. So that means that in any given project, you can set a conditional disable flag and basically enable or disable all of the assertions throughout the application with that one flag. And then if you build an executable based on that, then they'll either be compiled in or out, depending on what that flag's set to. And then, where's my cursor gone? So that's all of that information is bundled together here, and then chucked into a queue, which goes over to an application, kind of what's called an assertion manager, which is just a queued message handler application that sits there and waits for all this information to go into it. So this is actually a slightly old version of the VI. I'll show you the new version, which has just got a few more bits and pieces in it in a second. So that VI that I showed you just there is what's contained in these two small sub-VIs here. So you can see I've got one where I've got a double floating point number, one with an I32 wired into it. Oops, didn't want to do that. And then I've also created another couple of VIs here, which basically configure and set up the assertions. So one of those is called the preload of the search string. So you can preload a load of these asserts into the assertion manager application and then initialize them with certain values. And that means if you set up a load of assertion tests with this, where's my cursor gone again? This VI in the middle here, this is setting up the assertion tests with basically a string that's passed out. So, and within that string, you can say if this test pass it, or if this assertion is above this value, and this assertion is above a different value, then fail the test or then pass the test. So you can combine lots of different assertions to get quite complicated algorithms that pass or fail the assertions. So the reason for the preload asserts function is so that if you have some of those initialized or some of those one of those algorithms generated, and you only sort of have a valid value for one of them, then you could fail an assert before you've really got going. So therefore, I've just kind of put that into, so you can initialize them to a value that won't make the assert fail. I've actually combined these two values, or these two sub-VIs here, into one sub-VI now, so it's a little bit neater. But I'll show you how that works in a second. And then in terms of the default output, this is the report that gets generated now. So it's a pretty simple report, just using the LabVIEW report generation toolkit. At the top there, we've got the assert string that tells you. So this is the name of the test, test 1 here. And then DBL underscore assert is the name of the assert. And we're just saying if DBL underscore assert is less than 100, then it passes. If not, if it's over 100, then it fails. And then you can put a comment in here as well to just, it basically ignores everything after the double / so you can sort of put any information in there as you want to. And then at the end of the string, there's an options string where I can actually, it ignores everything after the double / I should say, until it sees this options string bit at the end. If it sees that, then it looks at that, and that's where you can configure whether it aborts or generates a report or does some other things. Then we've got a picture of the front panel of the assert VI, just so you can see what values are in there. And then we've got the call stack here as well. Asynchronous messages was based on some feedback from, I think it was James Powell or Stephen Mercer. I think it was James Powell at the CLA Summit, who had the idea that if you have a large application, you're probably going to have lots of different asynchronous processes going on, and they're all going to be communicating with each other. It could be with the Act framework, it could be with some other Kube message handler or something. And you might have found that one of these sort of processes works perfectly well on its own, but then when combined with messages coming from all of these other ones, that's what puts it into kind of an error state. So it might be important to log what those asynchronous messages are. So that's why I've got a section for asynchronous messages in here, which at the moment I'm still trying to figure out how to get that fully working. But the idea is it will log the last 10 or 100 or so asynchronous messages and then just give you that out as a set of strings, so you can go through and debug that. So before I talk about the GitHub, I'll just show you how it works. So along with, from that GitHub link, which I'll go back to in a second, you can download a VI package. If you install the VI package, then it will install this example along with the actual toolkit itself. So it's a very simple example. If I just open it up here, there's quite a lot of comments on here. So this is just an image of what the block diagram should look like once you've configured the example. And then down at the bottom, there's a ton of a big long comment there, which is basically information on how to run the example and how to use it. Let me just copy that string because that's important for in a minute. So what I decided to do, try and make this a bit sort of easier to understand and a bit easy to use, is start playing around with quick drop shortcuts. So if I go into control space and then control A, I've got a LabVIEW VI that comes up here. And so this is my quick drop shortcut. So I've just got a couple of options over there on the left-hand side. define an assert variable or define a new test. So if I say I want to define a new variable called dbl underscore assert, spell that right, hit enter, and then it scripts a new VI, which is a new instance of this assert VI with the actual, let me just bring up the context cell. So it's got that assert name built into the VI, and then I can just wire that in, and that's all I need to do to define that new assert. And then I'll just do another one for the I32 assert. Trying to be very careful here not to knock my laptop over and pull the projector down. And then the other part was to define the assert test. So if I don't want to do that, pressing the wrong things. Going quick drop again. And this is where you can define tests. So again, there's some instructions over on the right here about how to actually define the tests. One thing that I was thinking about is the fact that if you've got a large application, then you're going to have had lots of different asserts throughout lots of different sub-VIs. And initially I was just pulling all of the asserts from the current VI and populating this list box down here. So you can use that to define your basically your sort of strings to set up tests. But so that's what this bookmark here with the hashtag asserts is for. And that just means that as well as looking for actual asserts on this plot diagram here, it's going to pull all of this string out of here and populate the list with those asserts as well. So it's kind of I've tried to make it a little bit like intelligent about how it does it. So I can say test1 equals test, open brackets, and then if I want, I can basically select one of these asserts. So dbl underscore asserts selected. If I hit Control Enter, then it adds that in, and then I can just say it's less than 100, and then I can put in and or operators. So I can put multiple asserts within the same string. So you can define quite a lot of stuff from there. What I'll do is just do quickly is just copy and paste the string in from the block diagram. Hit enter, and again it's just scripted a new VI, which has got those asserts built into it. And then I just want to wire up this preload assert string here, which is an optional input. That just loads those asserts into memory. If you don't have that string connected, then it will load them in the first time you use it. It's just that would be useful if you had more complex testing. So if I run that, let's just so the test was, or one of the tests for the dbl underscore assert was if that test is if that value ever goes over 100, then it flags an assert. And what I'm doing to generate the number is just take a random number between 0 and 1, multiply it by y. So at the moment I've got it set to 100, so it's never going to fail. If I set that to 1,000, then fairly quickly it's going to trigger the assert, which is this directory here, and you can see that's filling up with more and more reports there. So I just stop that. And then open up one of these reports and see that's got all that information in that I showed you on the slide a minute ago.
If that takes a screenshot.
Yeah, I need to. That's actually a small bug because I wanted to, rather than have the screenshot of the assert VI, I wanted it to be a screenshot of this main VI to show what the state of information there was. So I need to put something in to say this VI's caller or something. But there's quite a large call chain, so and it kind of gets long and short depending on where the VI is being called from. So trying to get the right VI reference is a bit tricky. And that's what's the problem with the asynchronous message VIs. Because one of the other things that I've built is an add-on to the Active framework, which adds into one of the Active framework VIs a thing that includes a message into a buffer from the receive message function. But again, I was having problems with that yesterday, where it was getting the wrong VI reference.
Was it all text-based inputs, or could you almost put in a LabVIEW case structure where the default would be the assertion and all the other numbers will want you?
At the moment, it's just that I've only got that text-based string input, but there's nothing to stop you expanding it. I've left all the VIs open completely, no passwords or anything. So if anyone wants to improve the performance or make it more usable or anything, then I'm happy to play around with it.
Yeah, I the script that you got.
Yeah, that was quite fun actually, building those. Discovered a couple of undocumented features in LabVIEW along the way.
Only a couple?
Only a couple, yeah. Such as, yesterday I discovered another one, which was LabVIEW 2015. If you press block diagram cleanup on the receive message VI in the Active framework, crashes LabVIEW. Great.
I like it for that feature.
Yeah, undocumented feature. But yeah, if anyone wants to download it and play around with it, I'll put it up on GitHub. I know Richard Thomas has been playing around with it and doing things with it as well. I don't know how to determine how many people download it. I know a few people who download it and play around with it a bit.
It shouldn't be a thing on GitHub.
It probably should, but I just haven't looked that hard.
Yeah. See, I was just actually going to ask a question about GitHub. Is there a lot of LabVIEW stuff on there? Because I know it's obviously the main place
more.
Yeah. I know it's like the main place for stuff like kind of open sourcing your projects.
The last 6 months I've seen a massive.
I don't know.
We moved all our stuff over to it, probably.
Which Wi-Fi?
It's the top one. The top one.
Because that's like just kind of the conversation we were on earlier about kind of networking with people in web as well. It's another way to do it. So kind of find people. I don't know what easy it is to search it, but kind of find people on there and be like, you're in London.
Yeah,
contact us about LabVIEW.
Yeah, that's true. I've not played it actually.
I guess maybe it's worth opening it up and see if there's any questions from the web.
Yeah.
I was actually wondering, relating to the distribution method of the toolkit. It seems like a very useful toolkit. Will it be part of the VIPM? Like, if I open VIPM, is it in that list there?
It's not. I've made it into a VI package, but I haven't actually published the repository so the VI package manager automatically picks it up. But you can install it with VI package manager. You just need to download the package
from here. Yeah.
Make sure not VPN.
Bring Twitter.
See how many people have downloaded it.
Should I get your slide up about the kind of future topics?
Yeah.
Is there any questions from the web at all?
No, not at the moment. If anybody has any questions on the web, now is a good time to ask.
Go for it. Come back to it. Thanks.
There you go. So how do I tell how many people download it from here then?
You might have to get to the web interface.
Okay. Oh, I've got lots of copies of it open.
There it is at the side.
Do you mind if I unplug you or you still showing stuff?
It doesn't.
There's 3 people watching. Yes. Yeah. Yuri Kent is senior systems engineer from in Europe somewhere. David Starver's pretty senior in systems engineering over in the US.
Okay, cool. So, yeah, just a bit of a wrap up and a bit of a discussion as to what we want to do in 3 or 4 months' time. I can't remember whenever the next.
November.
I think we're going to do it after NI Days, so a bit of a follow up from NI Days.
Yeah.
So this slide is a direct steal from Dave Swan from the Sheffield User Group for their discussions as to what they want. So, you know, we can almost use these things as a kind of form of training on kind of advanced topics or specific topics, or have companies come in and present that you guys might have come across that are looking for a very polite group to first listen to. I think we're completely open to everything with this, really. I don't know if there's any topics that you guys are thinking of right now which you might be interested in somebody putting together a presentation in the next 3 months, or having one of the NI guys come in and present on.
So, well, it's coming out of me, that FPGA one, I'm going to be doing a very similar thing for a specific customer, but they're nowhere near here, unfortunately. Soon, so like I could, if people are interested in that, I'll have the content there already.
Yeah.
But I'm wondering if you guys are, I imagine, pretty clued up on FPGAs. And who's going to be there?
Yeah, well, I think that's an interesting one generally, isn't it? Because also, you know, we might get a bunch of people that are kind of brand new to LabVIEW. I think this, like the last 3 we've done, everyone's actually been pretty advanced. I think that's because the very first one we had a couple of guys that weren't, and that I think the Dan Boxer gave the active framework presentation.
Oh god!
So scared them off. Yeah, I think so. Yeah, but that's certainly. Well, obviously everyone knows the basics of it here. We just kind of played around with serials and stuff. But there's certainly, you know, a kind of angle on it. But I think. Yeah, the advanced.
Well, yeah, like I say, the content's going to be there anyway, so if you find something that's more relevant, then if you need me to do it, I'll do it.
Yeah, no, that's cool.
I have a customer who gave a presentation at the Automated Test Summit on using SQL databases for managing production line test and the data that comes off that, kind of tracking units of the test all the way through the production process.
Yeah.
And apparently the presentation went down very well at the Automated Test Summit. So if they're interested in that, I'm sure he'd be interested too. He's actually in the Southeast, so yeah, he's quite keen to get more involved in presenting and being a part of it.
I think it'd definitely be good to always get an industry use case in all these things, because it's great us going for a real nice tangent and maybe geeking up and stuff, but actually it needs to be relevant at some point. And again, it's the angle. So I love all the AI stuff, like sitting and kind of having Bo Skills bring that to us each time. I think it's quite cool. But again, that's quite niche in itself.
Would you be interested in maybe if I can get hold of one of the guys who's doing research, if they're based in London, in neural networks with FPGAs?
I'd love that, yeah. That'd be really cool. Yeah, certainly us as Austin would love that. Yeah. So
I'd find that interesting.
There you go. Yeah, I don't know, like X controls. I know you're going to be playing around with them.
I'm looking forward to learning about them. So I would definitely like to see a presentation on them, if possible. Or I could
give
I've got a cool X control project in my head, which I'm thinking I might throw in your direction, and you can then possibly present if people are interested to know about.
I think there's already some content from NI, because I did one before I even left. That was like years ago. So yeah, there's definitely some.
So we can combine the two. Giving use case. Like Vision, I think you'll have something cool very cool by the time we finish this demo. But again, I'm guessing kind of almost we need to set up some page that we could throw out like, and have that kind of voting system that they have for the CLA.
Forums allow us to do that.
You can do polls on there, can't you?
Yeah.
Because that may, again, you know, if we put out a few like, polite topics, that may encourage some other people to rock up that maybe did see the hidden markup model and think it's probably going to be a bit over the head.
Maybe they can even ask questions and then have answers in the user groups.
Yeah. Well, that maybe that would encourage more because we've done the whole Ask the Expert thing 3 times.
Yeah.
And I don't think anyone's ever come and asked a question. So, as much as we always think, you know, right now we have a lot of people paying a lot of money for our guys around the country.
Yeah.
We're saying, okay, here's our free time, and no one ever takes us up on it. So,
yeah.
Yeah, maybe we need a different approach to that.
Yeah, like I can think of a very kind of specific like company I think they would really benefit from stuff like this, but they're a bit far away. Like I'm trying to think if they would come or not, so I have to speak to them. But they could come in online.
Yeah.
Near they kind of, so I had like really good discussion with them yesterday, and I was like kind of talking about setting up like an internal user group for them, because just having me there meant they all spoke to each other.
See that a lot.
Yeah, but I think like it makes, you know, the more heads you have, the better answers you get, and I guarantee you will get better answers than me for a lot of the things that they were asking. So yeah, I'll get on to them. I owe them some information, so I'll try and get them involved even online if nothing else.
Yeah, and it'd be cool, like I said, when you guys are around customers, just finding out what they might like. Because one thing I would say is we're uber flexible with this.
Yeah.
Like I said, we can do it in the evening in a pub, or we can do it like, you know, on a Friday morning in whatever people want, really.
So that best practices and tips for faster coding. I've got some customers who've had some problems recently with best practices, and not just coding, but also other things like transitioning to a new version of LabVIEW, things like that. And it might be nice to have a kind of open floor discussion on something like that, even maybe in more of an informal environment like a pub.
Yeah.
That could be cool. We've actually got our best practices document we kind of put together, which could be a nice like opener for each subject to start a kind of, you know, conversation. And certainly, you know, something on LabVIEW 2015, how people are getting on with stuff could be quite cool.
Yeah, and I think as well, like from like an NI perspective, I suppose. Like I know, like it's obviously good to introduce the new products, but I kind of like what I would really like. I would just like come to this whether I worked for NI or not. Do you know what I mean? So I find it interesting. So I think the more we can generate people just discussing stuff, the better. And because I don't want to kind of feel like we're gonna sales pitch, like because that's not really what it's about. You know, you kind of want like people to bring their problems.
Yeah.
And, like that's what I really like to get from it, kind of feedback which we can give to R&D. And kind of get like, it'd be really good to have people kind of have things comfortable to complain about all the things that are annoying, and then you can either say we've got a solution or
and that's again, which is why I also think on the video stuff, maybe we actually don't sit and have a live stream going out the whole way through this. Actually, just video some presentations that people want to encourage people to come and be very open about what their problems are, because you don't want to be presented to the world with something that, you know, you might think is a silly question to ask. We've all been there, so it's not. Don't want to disencourage that. That's even a word. Now published to the world, so it's definitely a word. Both formula said. Yeah, that would be a cool setup. Yeah, I think that would be a better way, the more kind of informal, the better way. So you don't really want it to just turn into a lecture that you sat at the back and being like, I don't want everyone involved.
Maybe we could do something like bring a cool demo as well.
I think that would be a good way of coming across as NI without doing the sales pitch, but still showing the cool tools. Because, you know, even though I've just been at NI Week, like there's one of those slides I want you to go back and show me where I was on the academic side. That's cool. Yeah, thanks. thing that you kind of flip through. I was like,
Was it the concert?
yeah, we'll head back to that.
Yeah.
But it is cool, like, and so we are all into the technology and into what it is. So sometimes, like, I mean, certainly at NI Week, it's a big sales pitch, but actually there are stuff in there you're like, wow, that's really cool. Like the whole, which is the one where they were kind of going into the mountain with microphones, where they had all the FPGAs rolled up. It was like 800 channel FPGA. I can't remember what it was. I was very hungover at the time as well. But I was like, wow.
I don't remember. It's all work, wasn't it?
It's all tough week, yeah. But yeah, I remember thinking that was blooming awesome.
So maybe on that sort of kind of thing, obviously we showed a couple of videos today.
Yeah.
Would people be interested in hearing some more kind of UK-based, interesting case studies, maybe more presented by us than?
Yeah, and I don't think it has to be UK-based as such. Like, that's cool, and there I'm definitely. I've never seen those guys on
UK
stage.
is definitely doing some of the coolest applications.
That's,
in the world.
yeah.
I think it's nice to show that. Not everyone can get to the GST.
It's kind of inspiring as well, because I mean, I got to go to the GST or like my student project, which I didn't think was even get recorded. There were other people in my team. But yeah, like we came second in the world. Like the UK have come first a load of times.
Yeah.
Like people done some really amazing stuff, and I think like people need to realize there are UK companies on the world stage there, and they can do that. And a lot of the time it is without its partners. Or it is partners.
Yeah.
So
I think I was
it's quite inspiring.
shocked at that week how many Brits got up on stage. Like every once in a while. So I was thinking that guy's English.
Well,
Like,
we tend to, I don't know, there's a slide that we show when we